Hello, everybody. How's it going? Yeah? All right, well, tonight I'm going to talk about something not quite as funny, but I'm going to talk to you about memory. Yes, there we go. So memory is something that we all probably use every day. I won't judge you. I don't know you. But we don't really understand a lot about our memory, even though it's a really important part of who we are and what we do day to day. When you ask somebody about memory, they think of it as a filing cabinet or a Rolodex where there's simply just a file that they can go find. You search under B, you find your birthday memory, there you are, you're done. Psychologists think this too, actually, and it's called unidirectional fixation. And basically what this means is that memory is jammed in there somehow. You make it, you form it, and it's there forever. And so a lot of research is based on this idea too. And so if psychologists think it, if we think it, it's right. Yeah? No, not quite. I have to be the bearer of bad news and tell you that this could not be more wrong. The process of forming a memory is creative, and so is the process of remembering a memory. But before I get too far ahead of myself, let's slow down and talk about what it means to actually form a memory. Basically, there are three main stages that form this process. And these three stages carry you from making the memory, forming it, retrieving it, and then putting it all back in your brain again. So, first things first, when you're making a memory, this stage is called encoding. And essentially, all that encoding means is, hey, pay attention, and you're going to remember stuff. And what happens when you're paying attention is you're forming actual physical protein structures in your brain, and this is what helps you later remember a memory or a sequence of events that go together. It's interesting, though, because research has found that at this stage, we can stop you from forming a memory. The easiest way is to distract you, but there are also other means that we can use, such as drugs, which we'll talk about in a second, don't worry. The second part of forming a memory is storage. And we've all heard of long-term and short-term memory, and that's basically the gist of it. The more that you use a memory, the more that you recall something, the stronger the connections are in your brain. But the caveat to this is that you may be adding things to your memory that weren't there before. Think about that story that you just told last night and how different it is than the first time it happened. And in case you were wondering, there's way more crammed into your brain than you're ever going to be able to remember. So it makes our brain a little bit of a mysterious black box that we don't understand, which is perfect for psychologists. So, the final step in this process of forming a memory is retrieval, and this just means you're remembering things. It's at this point, though, that your memory is very susceptible to distraction or to suggestion. And as soon as you've retrieved the memory, it's as unstable as the first time you made it, and it has to be encoded once more. And so researchers have also found then that during this stage, when you're remembering things, you can change your memory or erase it. But don't worry, we'll get there too. So what I've just outlined for you then is the simple life cycle of what it is to make a memory. You start in encoding, you go down to storage, you retrieve it, and after retrieval, it re-enters your encoding process almost exactly the way it did the very first time that you made your memory. Are we clear? We're good? Okay. So now I'm going to introduce something called anisomycin. This is a protein synthesis inhibitor, and those big words mean it busts up the protein structures that I just told you memory was made of. And this is a big deal, because if I'm telling you I have a way to ruin that protein structure, what I'm telling you is that I can erase your memories. Well, not me, don't worry. Don't be afraid to talk to me later. But researchers have found that they can erase memories simply by introducing the substance into brains. Now, I know this won't come as a surprise, but the first candidates for this type of procedure were, in fact, lab rats in a laboratory. These poor little guys have had memories ripped out of their brains from as much as 1 day, 1 week, 1 month, or a year down the line of forming the memory, suggesting that at no point in time is that memory more stable than it was before. Now, rats, okay, we do a lot of stuff to rats, but we're also using these types of treatments in drug form on patients with PTSD. And while we haven't actually removed memories from these patients yet, we've made some startling progress by the way of removing the fear of the memories, which is one of the biggest parts of forming your memory. So why does this matter to you? You don't have PTSD, I hope. You're not a rat. But what I'm telling you is that something that's fundamentally a part of you, something that defines who you are, could potentially be taken away. Think about it for a second. What if I told you right now, forget everything you know, forget everything you've done, and everything you remember? What do you have left? Who are you at that point? I don't know the answer. It's interesting, though, because as far back as the 1800s, when anesthesia first became common, we had the same worries. People were worried that anesthesia would separate you so far from your consciousness that you would no longer be yourself. So does this mean 100 years from now, memory erasure will be nothing? I don't know. I guess only time's going to tell. What do you think? Thank you very much.